In this lecture, we will mainly discuss about awk programming, it is a script language, how to manipulate the data files or the output obtained from the any programmings and so on. So, in the past few classes, we focused on different aspects of bioinformatics and the application of bioinformatics, including the development of databases and algorithms and how to deal with this different specific type of algorithms we developed for protein sequences or DNA sequences and so on. Also, we discussed about various properties or features derived from known amino acid sequences or from these 3D structures, and then we discussed about the applications of the different bioinformatics database and tools for predicting the 3D structure of a protein or protein folding rates, protein stability as well as protein interactions. In the last class we discussed about the computer drug design on different aspects such as docking or the pharmacophore modeling, or we discussed about the virtual screening and the quantitative structure activity relationship. The quantitative structure activity relationship, say QSAR, right. So, what are the various aspects we need to consider?
Biological activity.
Right, mainly the main aspect is the biological activity can be described as a function of the molecular descriptors like the structural parameters, right. So, you can use various types of descriptors, right, for example, the 1D QSAR like molecular weight or hydrogen donors and so on, and you can give the connectivity as well as you can give the information regarding the surrounding residues in an environment. Then we can relate these parameters with the activity and to measure the performance, whether this we can get the good confident or not, right, by means of the correlation. So, depending upon the correlation as well as the cross validations, right, then we discussed a few examples, right, mainly on the BCL2 and the EGFR mutants for the cancer. So, we try to see how we can identify new compound by fitting the QSAR models. Okay, in this class and the subsequent classes, we discuss mainly about the algorithms as well as how we approach a problem, right, for a project or any type of analysis. So, awk programming is a scripting language, it is a kind of pattern matching program, right, for processing files, because when you deal with the several databases or when you write program for analyzing any structures or sequences, you will end up with getting a bulk amount of data. So, doing the manipulating the data, it takes time. So, in this case you can use this awk programming to get the desired output, right, in a very simple and easy way. So, it is a kind of pattern matching program for processing files, especially if your databases, right, or any output you obtain from these programs. So, this is a data extraction and reporting tool that uses a data driven scripting language, right, which consists of a set of actions to be taken against any data, right, for the purpose of producing the output, right. You have any specific input data, you want to process the data with respect to any action you can give, and what you want in the output, you can format the output as per your desire. So, this is the main applications of this awk programming. It is simple programming, but it is very powerful to handle large amount of data, especially parsing several data files in bioinformatics. For example, we discussed about various databases, right. Can you remember any of these databases? Protein sequence database UniProt, protein structure database PDB, right. For example, if you are interested only on the coordinates in the PDB file, right, you just writing one line command, right, you can get only the coordinates in the PDB file without looking into this PDB file. You do not have to open the PDB file, just if you know the input name, right, in one line you can get all the information regarding the coordinates, right. So, this I will explain how to use this awk program to get the files. So, it is very powerful program. So, it is one of the earliest tools, right, it appear in Unix, right. Now, then we can get the popularity now to use the various other features, and also you can use other combine other programs, right, to make a program using this awk. So, we talk about awk, it was created in Bell Labs in 1970s, right, and the names came AWK, that is from the family names of these authors. So, 3 persons, this AHO, right, and Weinberger and this Kernighan. So, with the names they put AWK. So, this is how they made this initially they started the name awk, right. So, what can we do with awk? So, what are the various applications of awk, right? You can handle a text file, right, made up of any records and fields, any text database, right, and you can perform the arithmetic and sorting of string operations. You can also search with several strings. You can also do arithmetic operations, right. I will explain some examples how to do these operations, and you can use programming this by constructing the loops and the conditions. You can also write a program using this awk, right. So, also you can use to produce the formatted reports, right, in a specific format. Then there are different types of awk, right. Over the first original form, this is the awk, the original form, right. Then they developed new versions, right. One is the N awk, right. This is a newer and improved versions, right. Using this version, you can execute Unix commands from a script, and you can process the results of Unix commands, and also you can do the work more easily with multiple input streams. Then if you take the G awk, this is another version of this awk. This is free software which is available from this foundation version. So, there are also perform very more powerful string of substitutions than the previous versions, like a simple awk or this N awk, right. So, what is the syntax? How the program awk works, right. So, in this case it is a kind of pattern action statement. This is syntax awks, you can give some options, and this is script to give you variable equal to value of these files. So, this is the pattern how to write the syntax for the awk. First you write awk, okay, this is the programming name awk, and you need the input file name. So, right here this is your input file name, you can put the input, right, and here the action means what you have to do, right. For example, here we have to do the program tells we need to print. So, which one we need to print? First column with the $1, this means a column, right. For example, if this is the A, B, C, D, E, this is column 1, this is 2, 3, 4, 5. So, you use this dollar symbol, right, to specify the column. So, this is the action means what we need to do that. So, here we have to print only the first column. So, first column means this is the first column, print this, and this is a pattern. Pattern means if it satisfies which conditions we need to print, we need to do the action. So, we can give some conditions, right. For example, if there is no empty line, if any line contains some characters, or any line contains any numbers, or any line contains the numbers more than 50, right. You can find any pattern, right. If it satisfies the pattern, then do the action, right. Here it says just print, right. This input file. So, here input file is abc.date. So, it considers the condition n of greater than 1. I will explain what is this, right. This will check this condition in this file abc.date, and if it satisfies the condition, then it will print the first column. Okay, this is the syntax for this pattern action statement, that is the awk. So, I show some of the input files. So, some of them are familiar to you already, I showed several times, as some of the new files. Can you see this test2.date? What is this?
PDB.
It is a kind of PDF file, right. So, you can see the source, compound, sequence, right, helix, atom and so on, right. This is a PDF file you can get from the protein data bank. So, the test1 dot, right, here this is the output obtained from a program, right. You can see the various numbers, this is the some scores and some IDs, right. So, and some blank lines. So, these are the various types of information available in the test1.date, right. We can use this data for the manipulation. So, this is text3.date. Are you familiar with this output? Okay, this DSSP output, this you obtained from DSSP. What is DSSP? Dictionary of secondary structural proteins, right. So, you can see this one. So, here we have the command lines, right, how they identify the hydrogen bonds, right, and so on, right. So, here from this it starts the data from 1, here we give the residue name and the chain information here, and here we give the residue, right, and this is a secondary structure, and you can see solvent accessibility, right. What is solvent accessibility? So, you know that how far the residue is exposed or it is buried. So, from this you can see that. So, from this one you can easily identify the residues which are at the surface, outside at the buried. So, because you have to search with this column, right. For example, if you need the completely buried, say less than 5 angstrom square. So, see this column and see where we have less than 5, for example, here, right. So, you can use write one line awk code, right, to get the residues are here, right, it is here, right, which has the ASA of less than 5, easily you can see that, right. Okay, here I get few more data files. Here I give one data, this is output of another program test 4, and test 6 again it is a PDB file. So, what is the specific information in test 6?
Atom records.
Atom record, this is mainly the atom record, we have the coordinates, right, explicit coordinates, right, this is test 6. This is another file text file, this is the output obtained from the another program, this one. You can also see how to use this test file also to do some kind of arithmetic calculations. Okay, here is some list of input files, this is list of input files, so this is the number of lines and this is the file names. So, this is input file names. Here this is the PDB coordinates, we have only some information, not the complete information. Right, this is also this not in format, right. There are several misalignments in this particular test 9 and test 10. Okay, now we will show with some examples. So, we have several input files and we desire to get the output files, right, based on some of our requirements, right. In this case, I will explain few commands using awk, how to manipulate the data, how to get the information what we need. So, first one is start from the simplest one. Okay, we have a file, okay, this is the input file, right, this is the input file, and the first question is print column 6, right, which one is column 6? 1, 2, 3, 4, 5, 6, this is column 6, we need to print, right. So, in this case, do we need any pattern? We do not need a pattern, because we are not looking for anything, just we want to print the column 6 because it contains some numbers, I want to see the numbers. So, here you put awk, right, and then what is the action want to do. So, there this bracket is very important, right. So, you have to give the action within quotes. So, you put the print, what do you want to do is you have to print the 6. So, print this is 6th column. So, you mentioned all 6, right, then you will get the output. What is the output you will get if you work this on this file,
6
right, 6th column like 32.18, 11.41, okay, this is just you can see this output, this you will get, right, that is fine. So, for example, if you want to print 2 columns, for example, $1 and $6, right, you need the, because this is only the numbers. So, I want to get the quotes plus the numbers, right. So, in this case if you want how to do this is awk, and in the quotes you have to give the action, you have to print $1 as well as $6, right, then you give the input file name, this input file name, right. Then you will see, okay, this is the first column and this is the 6th column, right, you get the answers. If you see the input file, this is your input file, this is the 1, this is 6 and you get 1 and 6. Now, the question is it possible to write in reverse order, right, I do not want to get this 1 and 6, I want to write the results in 6 and 1, because I want to deal with the 6 first. Is it possible to write the data in the reverse order? It is possible. How to do this in this case? You can see the order. So, here this will follow the same order what you give in action. If you ask to write first column, we will write first column, 6th column, 6th column. If you want to write several columns, what are the order you give, accordingly you can write. So, if you want to first and 6 means you will get first and 6. If you write 6 and 1, what will be the result? Yeah, this will be like this 32.1852, then 1 PRXACA like this, right, you can get the answer. Okay, now here this is a screen. So, if you write just the input files, right, and if you give the awk command, you can see the data on the screen, right. For example, if you want to write the answer in a file, right, in this case what to do, right, we have to give the greater than symbol. That means the result obtained from this command will go to this file, right. This is the extra we give, okay. This is the same awk print 1 comma 6, right, and you need to specify where you want to write. So, you could put the greater than symbol, this is the output will go to the file what you specify, right. So, you can see test 1 dot result, right. If you do it, where can we see it on the screen now or only on the file? It is on the file, right. So, if you do like this, then the next will come with this dollar symbol for the next command, because if you open this file, right, then you can see if you open test 1 dot result, there you can see this 1 comma 6 means this result, right. This is stored in test 1 dot result, right, that is fine. So, for any operations you can either see your results on the screen or you can write in a file. So, now here question, if there are several empty lines, for example, if this is the data, there are several empty lines, right. In this case, how to eliminate the empty lines? I need the file without empty lines, right. So, here we use this NF, NF is number of fields. What is the meaning of number of fields? Number of columns, how many fields we have. So, if you want to eliminate the free lines, so at least this contain only one column, right, one field. So, in this case you put NF is greater than 1, right. You can see the codes starting from this your conditions till your action, right. So, here the condition is NF is greater than 1. What is the meaning of NF greater than 1?
Number of fields.
The number of fields will be more than 1, that should be more than, if it is more than 1 then you print, right. But here you will get the results in the screen or in a file?
Screen.
On the screen, right, you can see it on the screen. So, here if you work on this one, right, then you will get this result, right. These empty lines are eliminated, right, all others are fine. Type 3, this empty line is eliminated and this empty line is eliminated, right, this is fine. Okay. So, now next question is, okay, I have a file, I want to number each lines, right. So, in this case what we had to do. So, here we have this command FNR, FNR gives file line number, right, for each fields, each line this will give a number. So, if you want to number all the consider all the columns and print everything, right. So, print FNR, FNR means give the file number and $0. What is the meaning of $0?
Entire line.
Entire line. So, if you write $1, what will happen?
First column.
This will give only the first column. If it is $0, so that means the entire. So, write the entire line, right. So, in this case if you see this one, okay, whether the output, this is the input, right. So, get the output. So, did you see that they added the line numbers?
Yes.
Yes, right, you can see the line numbers, but this is merged with this first column, right. So, in this case it is very difficult to see where the numbers are. So, in this case it is better if you add a tab or add some space between these two, because there is no space. So, it is merged, right. So, in this case what can we do? Is it possible to add a tab in between these two? Yes, it is, we can add it, okay. You can have this command, the same print FNR $0 test4.date, right. But here we added another information, that is tab, that is \t, right, you put in quotes, right. If you do this, then it will add lines, right, with a tab. Now, can you see this result and the previous result? Here there is no space, but here you can see this is a tab, right. So, you can also give space, right, when we adding numbers. Now, the question is we can also count lines if you take many documents in a file. So, how many lines, right, In the Unix we give the command, what is the command we use to count the line number of lines? WC minus L, just you give WC minus L, this will give you the lines, right. So, here also you can give awk, you go from to the end, what is NR? Number of lines, line numbers, right. So, you can,
number of records.
number of occurrence. So, you can see NR, right. So, how many lines, right, when they go to this particular file test4.date, the input file. So, give the line number. So, count all the lines. So, you will give this is total 22 records, right, 22 lines in this particular file. So, similar to WC minus L in the Unix, right. So, now here the next question is print the last field of each line. So, we have several fields. If you know this is we require fifth field or sixth field, just you write print dollar number field 5 or field 6, right. If it is the last field, then you put $NF, right, in this file. So, what is the last field? This is the last field, right. Then if you do this, you will get the result. So, just is a simple awk command, awk print $NF, okay, with this input file text 6.8. So, we get the last field of each line. Then also it is also possible the last field of last line, right. Just now we saw about the total number of lines. So, put the end, right, when you give this line number. So, same we combine. So, this is the last field, this is end, and the print $NF, right, this is the last field of last line, that is O. So, you can see the result over here, right. So, likewise you can manipulate, right, any data file, right, as we require. Then I will show some of the important information where we can really manipulate the output files. So, here I put one condition, print every line where the value of the sixth field is more than 50, right. So, how to do this? So, you can see the sixth field, right, or the sixth field more than 50, says more than 50, then you print. If you just print, what will do? It will print the entire, either print $0 or you just give print. So, you can give the entire things if it is more than 50. So, is this more than 50? No, right. This is more than 50, $6, this is 1, 2, 3, 4, 5, 6, right. This is more than second one more than 50? No. Third one? Yes. Then again this no, this 6, right. So, you can see the same way. So, here you can see this is 96 is present here, and again the next 96 is present here, and 58 is present here. So, you can see the values, right, which is more than 50. Okay, now if I have this example, okay, I give the example. So, I want to see how many amino acids are in the buried region. So, what we will do, for if you have any PDB-ID, you can want to see the number of residues which are in the buried. So, you can run the DSSP. So, you will get this output. From this, is it possible to get the number of residues which are completely buried, for example 0, without touching any of this file? Is it possible to do? We can do. What we have to do first?
Select only records.
Yeah, select only the records, which number 1, 2, 3, 4, 5, 6, 7, 8, 9, right. Take this field and then see, you have to write the records if this record is more than 50. And second, what we have to do? We can do the number of fields. Likewise, we make two commands, and you can easily get the number of residues which are at in the buried, because if we take the condition of 0, right, these are the two commands we have to do. First, we need to check the file, right, if the column 9, right, which is more than 50, right, and then this will give you the residues which are having the value of 0. If it is buried, means you have to put that less than 1 or equal to 0, right, and then you can use this command, right. Okay, this is the command to see the NF minus L, right. So, then you will see how many records. Also, is it possible to identify how many residues which are in the exposed region with the condition of 75 angstrom square?
Yes.
Right. So, what we will do, we have to put this column number which is greater than 75, then you print, right, and you print this to output, right. This output will be the input of this the next command. So, here you can give this command, here this is the output file you give here, and this will give you the total number of records, right. So, in this he will tell you, okay, without looking into the PDB file or DSSP file, right, you can see how many residues, right, which are buried, how many residues are which are in the exposed, right. Just first take the we have the PDB file, run DSSP, right, then give the command command. So, with the field which contains the value of more than 75, then you find the line number, right, total how many lines, right. Without manipulating or editing anything, you can easily get all the information. In this case also you can see how many alanines which are exposed, which are in the buried, right. Likewise, you can have different files, you can manipulate the files, easily you can get all the information, right, without editing any of these files. So, the next question, okay, print the lines starting from 15, right. Here this is your DSSP file, right. So, here you these are your command the information, right. So, actual result starts from here, right. If you want only this data as a input to the another program, because this they do not need all these necessary data. So, in this case if you want to have the lines, right, which are starting from 15. So, here you can come, what is NR? Records, right. So, in this case line number is more than 14, because we need from 15, right. Then you print from this input file. So, then you will eliminate all these things, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right. So, then you can start, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right. So, then you can get from this line, right, this line. So, you can give any number according to the number you give, so you will get the output. So, that means you delete the line numbers until 14, right, 14 lines, right. This is you can check or you can get these files. Likewise, you can do it any numbers, right, 15 or 16 whatever you like. So, you can do that. So, then the next question is you can separate the field separator. For example, if there is any field separator, this is the field separator, here you can see this one, whether we can eliminate, we can do this separate with this one. So, if this is the case, right. So, $2, so you can print the $2 like test1.date. So, this is the test1, right. Here you can see the field separator, this is the FE for field separator, and you can get this 2 here, right, the middle ones, separate these 2 fields. Right. In this case you can also do lot of other manipulations. For example, you can print alternate lines. In this case if you see this input file, so this you can say the same for one A1S, one A1S, one A2Z, one A2Z. So, these 2 are the same, right, only difference is A and B. So, I want to see the unique ones. In this case I like to delete the alternate lines, because that input is necessary for the another program. So, if you want to print alternate lines, you can omit the second one using this equation like the NR dollar this is ampersand and then 2, that means you will cut the second one, finally you get this result, right. So, this is here, this is omitted, this here, this omitted, this here, right, you can get that. So, if you want to omit the third line, right, then you put the 3. So, first 2 is present here and the third one, this 219 is omitted, and again start from this 2, right, and the third one is omitted. Here you can see the omitted ones, right, you can do for any lines if you want to omit. Now, if you want to do any substitutions, for example, if you want any mutations, so you can it is possible to substitute any text, for example, using this command sub. So, what do you want to substitute? Here you want to substitute LYS to ARG. Then how to substitute this lysine to arginine? So, here this is record for the lysine, right. So, to change this to arginine by giving this command, that awk we get this is the pattern action statement. SUB is your substitution from lice. So, in this case you have to put the slash wherever the exactly like you get the lice you will change to arginine. So, here if you see this one lice into arginine, this one example, but you can do the manipulation for the different files at the different places. What if you want to make any changes like kind of this replace command. Okay. Now in this awk there are several built in functions available. So, I explained a few of them. So, there are various built in functions available in awk. So, for example, Fs is the field separator I discussed earlier. What is NF? Number of fields in the current record. NR number of current record. Likewise, there are various other options like record separator. This is $0 is for the entire input record, $n is the nth field in the current record, right. So, likewise you can see this FNR like the NR, but related to the current file. You see any of these variables and get the description, right, and accordingly you can manipulate these files using this awk command. So, you can see some of these available in awk and you can see some more information, right. You can also use nawk, right, for more information. So, now the next we go to the next step. Now, first one is we discussed about the substitution and the printing the some lines, some columns, right, and doing some sort of file manipulations.